this section, we're basically looking at the chain rule again, which we recall is dy dx, which equals dy du times du dx, where u is some function of x. We know that from our chain rule. Okay, that's all that is. It's nothing particularly new. Now, the thing that the idea that we're using here for this section is when we have x being a function of y, so it's kind of backwards what we normally have. We usually have y equals a function of x. So in the same way that this is opposite, we're actually going to try and find dy dx again, but to do that we're going to find dx dy. And then the key thing there is to realise that dx dy, if we flip that over, is going to give us dy dx. So it's this idea here. And this is the proof here getting to the point. So dy dx equals 1 over dx dy. So if we can find dx dy, we can find dy dx. It's just flipping this over, provided this is not 0. So it's pretty easy. So the example we're going to look at here is example 5. So we have x equals y cubed, find dy dx. Okay, that's the example. I'm just going to start it up here. So we've got x equals y cubed. Now we need to find dy dx. We need dy dx, but because our function is x is a function of y, let's instead find dx dy, and then we can flip it over at the end, okay? And then we'll flip it, and that will give us dy dx. So we'll find this first. Now the way to do that is to take the derivative, use the differential operator, d, and you can see here you have dx on the top, we have dy underneath. We're actually going to use the differential operator d dy. So this is that idea that these two things don't match, but it's cool because that gives us the dx dy, which is what we want. If we do the differential operator d dy to one side of an equation, guess what? Got to do it to the other side as well. So we've got this differential operator differentiate with respect to y on both sides now. On the left side, nothing happens here except we leave it as dx dy. On this side, this tells us we must differentiate the function y cubed. And we know that as long as these match, we just do the differentiation as normal. So in your head, you can really think of this as x's. So differentiating an x to a power, remember the power comes out the front, becomes 3, and then the power goes down by 1. So that's it. In order for us to get our answer, what we need to do now is we flip. Okay, we flip over this side of the equation to get dy dx. We also have to flip over this side. Now you need to make sure that you remember anything that doesn't have a visible denominator is over 1. So when you flip this side, a 1 comes up on the top and you get 3y squared underneath. Okay, so that's it, that's your answer. So for this particular equation, which was x equals y cubed, oops, here, then the derivative, dy dx, is 1 over 3y squared. Okay, and that's using this idea of flipping. Now you could also have done this in a different method, so this is the alternate method. This doesn't actually make use of the section x equals f of y. What you could have done is rewritten this. So taken the 3 over to the other side, that then becomes a cube root, power of a third would be y. Then we could just differentiate both sides of that equation by x. So d dx are both sides. What that would give you here would be a third of x, take off 1 from that power of a third, so a third minus 1 is negative 2/3 equals dy dx. And so that would actually mean that dy dx equals this negative power, means that that goes underneath, and it would be x to the power of 2/3. So that would be the alternate way of doing this question. Now what you might notice here is those answers look completely different. Okay, but if you think about it, okay, x to the power of 2/3 and 3y squared, well if we were looking at what y actually is, and I know that y equals x to the 1/3, well if you put that into here, this would be 1/3 squared, and 1/3 squared is 2/3. So these answers, in fact, are identical. These are completely equivalent, and they are both correct. So in terms of which one you go with, I think in terms of the work, you can see there's a lot less work here. And you could at the end substitute, find y and substitute it back in. Generally, a question will ask you if it wants the answer to be given in terms of x. With the types of questions you're doing in this section, generally because the function is in terms of y, you tend to give your answer in terms of y as well. And that makes more sense that way. But both of these ways of doing this question are completely equivalent and completely correct. Just for most of this section, we'll tend to keep our answers in terms of being functions of y. So the key thing here, find dy dx by finding dx dy and then flipping.